Okay, so let's get back to coding. We took a break there to talk about different languages and stuff like that. Let's get back to coding. We're going to do some fun stuff with functions. We're going to mess with turtle. And we're going to import turtle here. And what is turtle? Okay, so those of you that played modded Minecraft way back in the day, you probably remember Computercraft and the Computercraft turtles. Okay, this is very, very similar to that. I mean, to the point where it is actually that, just not Minecraftified. Turtles are little objects that we can move around and do stuff with in Python. I do remember those. Yes, I love Computercraft. Oh, you guys are going to be so happy here shortly. That's how I got into programming. There you go. I love it. Okay, cool. So up here at the top, we imported turtle. And what is turtle? Turtle, why import turtle here? Okay, so turtle is a module. And a module is something that has already been written. It's code that has already been written that gets installed with your game. Okay, I am going to block you forever because you're trying to send me links. I'm not clicking on any of your links, but oh god, damn dude, messed me up now. But it's a module. It's code that someone already wrote that we're going to use, and it installs this right away. When you install Python, it installs the turtle module for you, so you guys have it. But there are other modules that you can install using a software called pip. If you need to look that up, we're not going to cover any modules in this stream that require pip, so I'm not going to really talk about it a lot. Watermelons, that's okay, buddy. You have a good day. We're not going to really talk about other modules. Just know that we're importing turtle here, and we're going to be using functions from turtle. So let's do this. I do have to remember, and Relly, you're going to have to help me out here because it's been a long time since I've done turtle stuff. We can create a turtle, and we can say that turtle dot, nope, that is not how I use turtle. This is bad. I've completely forgotten how to use turtle. Turtle dot do 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 do. Relly, help me. How do I make a turtle? That's how I do it. Okay. So we're going to call our turtle T. And then we're going to create a new turtle. That was a terrible explanation of a module. It is. It really was. I'm ashamed of myself, to be fair. No module named Tkinter. Dude, if you're messing with GUIs, I hate everything. Python GUIs are disgusting. Don't even need to initialize turtles. I'm going to initialize a turtle for the sake of initializing. So let's explain this line of code. So we use our module. So we are calling a function from our module turtle. Okay? And we are saying that turtle dot, and then we're going to call a function inside of that module. So in this module, there is a function called turtle that creates a turtle. Okay? So we are going to call the creation of a turtle, and we are going to store it to the variable t. Okay? And then we can say t dot forward. And we're going to move this turtle forward 100 distance. Okay? Do I know the exact measurement of what this distance is? Absolutely not. But now I can run this, and I'm going to get rid of some of this code here. Is the font too small? Because I can raise this a little bit. We can move this turtle forward. And when I hit go, it flashed on the screen, but then it stopped. We can say t dot t dot. Wow, I really thought I remembered how to do turtle stuff. This is quite bad. I'm very sorry. How do I make it stay, Relly? T dot do 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 do. Can the flash stay? Yes, it can stay. Relly will help me out here shortly. What type is T? It's not turtle.done. That's what I thought it was, but okay, T.done. So then this will show it on the screen here. My anaconda won't, my anaconda won't, my anaconda won't unless you got some Python. Oh my god. That's just a bad, bad joke. I love it though, in every way. Thank you, Rally. So this will then, turtle has no attribute done. That will work though. There we go. So now you can see on the screen, we have our turtle. It started right here. It moved to the right, and it stopped right there. Okay? Everything makes sense on that one. Let's move him forward 200. Okay? We can move him forward 200, and we can say that. Now he moved forward a little bit further than he did before. We can say turtle.forward 500, and he is going to move forward significantly further, to the point where he is not even on my screen anymore. There he is. I had to change the screen to see him. So that's cool. Turtle.dead. We're not going to kill the turtle. So let's make a square with the turtle. So we're going to move him forward 100. And then we're going to say, okay, T.left. We're going to turn this guy left 90 degrees. We pass in the angle into our function. Then we're going to say T.forward again. We're going to move him forward 100. And we're going to say T.left. So he's going to turn to the left another 90 degrees. And we're going to say, okay, T.forward. And then we're going to turn him to the left again here. And we're going to turn him left 90 degrees. And then we're going to do one last T.forward. And if I can count correctly in my brain, when we run this, we will see a square, which is very nice. We can do a repeat. We realistically, you would want to loop this, but we haven't talked about loops yet. So this makes a square. It's quite nice. It's a very nice square. No repeat. Dude, if there's a repeat function in Turtles, I never learned it. So I'm just kind of showing off basic functioning with Turtles here. But that moves our turtle nice and good. It is general practice. You want to bring the turtle back to his starting position whenever you're done with him. So we will turn him back 90 degrees so that he legitimately comes back and starts exactly where he or ends exactly where he began, just like that. But we've made a nice square. We can then do some funky stuff here. It's weird because, like, turtles, I really should be teaching recursion with them. Oh, I don't want to teach recursion right now. I'd rather talk about strings. I feel like I'm going to end up totally messing up everything if I talk about recursion. Let's just do something stranger here. So let's do some functions with turtles, okay? We're going to say we're going to define a function called square. All right? And we're going to pass in the length of our line. And that's it, honestly. We're just going to pass in the length of our line. We programmers always find a way to mess up everything regardless of what it is. I mean, you're true, user man. You're very true. I just would, I wouldn't necessarily like to mess up everything right now. So let's create a square here, and we're going to basically have the exact same functions that we had before. So T.forward, which you can just do, I thought that was a thing. Maybe it's that. Oh, well, I will type out forward. Oh, this is because we don't have a turtle anymore. I can just say turtle.forward, and that works out fine. Relly said it creates its own thing, so that's fine. We can do FD, right? Yeah, okay. I'm bringing back my turtle knowledge. And then turtle.left 90, turtle.forward 100. We're basically just typing the exact... Oh, we don't want to do that, though. We want to type in our length. I'm an idiot. We want to pass in our length because we want to clarify the types of how big our squares are going to be when we're doing stuff here. So we'll do that. We'll do another forward here of length. We'll do another left 90. Another turtle dot forward length. And then finally bring him back to where he started, just like so. And then a turtle dot done. So when we call our function here, we can call a square 100. And this is going to do the exact same square that we had previously. I have no idea why it decided to act so strange in that window, but created the exact same square that we had before. We can say square of 200, and it's going to create a little bit bigger of a square now. We can say square of 300, pretty straightforward as we go. You're going to see an even bigger square than what we had previously. So we can kind of dictate what we want to pass into our square. Is this leading into recursion? I really didn't want to go into it today, but maybe we'll do a little bit, because this is really a great example of recursion, is this. But what we can do, we can say, okay, square is equal to 300. Then let's do a square equals 200. And then let's do a square of 100. Then, hell, let's do a square of 50. And then finally, let's do a square of 10. So what is this going to look like? It's going to get real wacky. We're going to have some kind of concentric squares going on here that just continue to go down. And looks pretty dope, honestly. No complaints at all about how that's looking. And it's because we brought it back to that initial starting position. So this is why you always bring turtles back to their starting position, because if we don't have him turn back to his starting position, this is what it's going to look like. And it's not going to look how we necessarily want it to. It's a little bit strange. I'll tell you what, it still looks pretty cool. Like, I'm not going to argue. It still looks cool, but it's not the intended look that we necessarily wanted. Dude, my mouse is spazzing out on the right. That's very strange. So yeah, I mean, that's a pretty neat way of doing things here. We can also get a little bit stranger. Let's only turn left 45. And you should be able to know what's going to happen if we do this. So this is going to... Oh, I did not want to... Oh, it's doing all kinds of whack stuff. It actually looks pretty sick if we expand this. It does a little spiral because we are... I can't get it all the way up there to show you. If we pass in some smaller values, let's go 100 and then 75... 50 or 50, 25, 10, and run this, then it'll look a little bit different here. So there we go. Now we have our little spiral going on because we're going at 45-degree angles. It's pretty cool to just mess around with these little turtle boys. It says length is not defined for me. You got to pass in a parameter there, because if you're not passing in anything as length into your function, then it can't call it. It doesn't know what length is there. Does that make sense? So there, we've created some funky things. We can also this is what I was trying to do, and then I realized that it wasn't going to work how I necessarily intended. So if we do a turtle.left 45 and then change these back to 90, then what is this going to do? Let's run this and let's find out what it's going to do. It's going to make a diamond because we're moving. We first tilt it 45 degrees and then we continue to do 90s, and that's just going to make a nice little diamond here. We can do another, believe if I do turtle.left 90 at the end of this, then we can do some concentric diamonds like we had before. So square 250, square 100, square 50, square 10, and run this, and we'll see some funky stuff going on here. So big diamond. It's off the page. That's okay. Oh, I've messed something up. I'm sure one of you could figure out what I messed up. One of our angles is off, but it still made something cool. Still pretty neat. I like it. So that's kind of basic messing with Turtle. I know that you guys like seeing graphical stuff. which is why I wanted to show off Turtle. There's a lot you can do with it. If you're interested in recursion, I'm not going to get into it on this stream right now because I don't necessarily want to cover recursion because I am 99% sure I'm going to mess it up here. There is a video on my channel. I will post a link in the Discord afterward if you would like to check out recursion with Turtle. I explain it significantly better in there, so I would recommend you check that out if you want to learn a little bit about recursion. Your thing says Alexa K Love in it. That's because it has to be Alexa K Love. That's my emote. Because my stream name used to be Alexa Kid. Now it's Alexa Stream. I have not done any deep learning. Last 145 to fix it. There you go. Now we can get some concentric diamonds in here. There you go. Thank you, Sean. Appreciate that. There's our concentric diamonds. Looking all nice. It looks like a baseball field. A little bit here. Pretty cool. All angles need to add to 360. That is true as well. My math is not on right now. But cool. That's Turtle. Pretty straightforward. Let's move on to messing with strings and lists because I want to cover loops before we end today. Like I said, if you're interested in recursion, then you can check the Discord after this. As always, you can join my Discord by going here. That is not at all the command. Here. And you can join the Discord, and we have the coding chat, and I will add any of you as coders if you want access to the coding chat so that you can do some stuff in there and show off some of your creations, but I'll post the video in there. Have you done any deep learning? Not really, actually. I want to. It's insanely interesting for me, but I haven't done much with it. Hey, Unstable. Welcome in, buddy. What is the program I'm using? This is Python. I'm using PyCharm. It's an IDE, has a built-in debugger, a bunch of other stuff. Hey, Tyler, it's me, the guy who didn't know how to spell your name, just watching Gungeon. I'm still watching the video and decided to stop by, so hi. How are you, Kernoel? Only here for his voice, don't like Python. Welcome in, everybody, stopping in. Let's mess with strings. Strings are fun. We can do a lot with strings. So let's define a string. I'm just going to call it my string. Okay, and we're going to define our string as this is a string. Okay, or let's do a better string. This is a stream on Twitch. Buy my merch. There. Okay. I don't even have merch, so it doesn't really work out well here, but buy my merch and throw bits at me. Okay, my string equals buy my merch. Let's mess with this string, okay? Let's say we wanted to only print buy, okay? How can I impact my string here to only give me back that? Well, we can index it. And how do we index things? We index things with brackets. And brackets allow you to basically take chunks of whatever you're doing and take from them. So we can say that my string indexed at 0. Okay? So all strings, arrays, lists, sets, dictionaries, everything. Hopdo, 100 bits. You said send bits, you madman. I didn't mean it. Thank you so much for the bits, buddy. But everything starts at 0 when you're talking about arrays and strings and indexing and everything. Everything starts at 0. Do not do 1. This is like if you learn anything from today, it starts at 0 in Python. Not every language, but most languages start at 0. Yeah, start at 0. So if we grab my string at the 0th position, what is this going to print? Dictionaries and sets start with 0. They should. Although I'm not positive you can index a dictionary or a set, so maybe not. All sequences in Python start with a index at 0 to start, but we don't speak of the languages that start indexes at 1. Yeah, I despise them. Okay, so my string indexed at 0. Dictionaries are keys. Yeah, you can't really index a dictionary. That was my bad. But if we index our string at 0, then we can get the 0th position of our string, which in this case is going to be the letter B, because that's the start of our string. We can print this, and we will see that my string at 0 is B. Now, let's say we wanted to print by, like I said. So we can say 0 to another number, and that will print a range of stuff. So the first number is always inclusive, which means it's going to include that index. The last number is always exclusive. It's not going to include that index. So if we're going 0 to 3, it's going to print indices. I almost said indexes. 0, 1, and 2 here. It's going to go up to 3, but not include it. So when we print this, we're going to see that we totally got busted here. Why are you busted? Oh, it's because I put a comma. I meant to put a colon. It's a colon, not comma. Relly got it before I did. There we go. My bad. My bad. We do that, and we can see that that's going to print out by right there. So we can do other stuff with this colon as well. So we can print my string indexed at 3 colon. So what is this going to do? This is going to start at 3, which is going to be the space right here. And it's going to index to the rest of the string. You know, we're not really saying anything else at the end of this. So this is actually going to print from index 3 to the end of the string. Okay, so we can print this, and we will see that's going to do space, my merch. Now, what if we just wanted to get rid of the space? We can say, okay, well, we'll index from 4 because that's where the M is. We can do bang, and now we have by my merch as our 3 things that we have printed. Pretty straightforward. We can also index a string at a negative number. We can index this at -1. So what is that going to do? So let's kind of create a diagram here. So we have by my merch. Okay. Here's our indices. So we have 0, 1, 2, 3. It's going to get messed up because this isn't in stupid plain text. Ultra Hell, thank you so much for the follow. Okay, just bear with me here. So -1 is going to index at the end of the string. It's going to go in reverse when we do this. So if we run this, we're going to see that it grabs the H from my merch. And if we grab, you know, -2, it's going to grab the C from my merch. And then if we do -3, it's going to grab the R. Pretty straightforward. Why would you ever do this? If you needed to grab the last character in something, or the last object in a list, which we're going to talk about shortly, then you can use negatives to get it. But I'm going to be honest, I don't think I've ever used a negative in an index ever. It's just a fun thing to kind of see here. You have a good one, Euros. I'm glad that you enjoyed. Relly just banned him? Relly, what? Okay, Relly has unbanned him. That's good. Wrong button. Euros, you have a good day, buddy. Okay, so we've indexed stuff. That's fun. That's good. What else can we do with strings? So let's say we have a string that looks something like this. Hi, I'm bad at spacing. And we have a bunch of white space on the end of our strings. We can get rid of that white space. We can say that, you know, my string is going to be equal to my string dot strip. And the dot strip function, you know what? I feel like I actually need to do this now. It's getting hot in here. So we need to dot strip. This will get rid of white space at the beginning and ends of your string here. So when we print this, we're going to, oh, it's not actually printing anything, but when we print this string, we're going to see that it got rid of the white space at the ends of those. And we can actually confirm this by saying, let's put a colon right in between the string. And we can say that, okay, print that. And you can see that it's colon, it's getting hot in here, colon. without the spaces. And if we were to comment out this line and just print it, then we will see the spaces in here as so. So strip is pretty useful for getting rid of white space if you're ever in a situation where you have white space on the end of a string. I am going to talk about dot split as well, but we're going to talk about that shortly when we get to lists. What other good string functions are there? So we can do all kinds of fun stuff. We can say myString.upper, and we can print that one right there as well. And what this is going to do, it's going to capitalize everything in our string. So we can print that, and you're going to see it's getting hot in here, and it's going to get really excited about it because we made everything uppercase. On the flip side, we can then do, say we have our string is equal to, hi, I'm Tyler. Or how about this? Hoi, I'm Temmie. Okay, we can say, let's print myString.lower, and that's going to make everything lowercase as well. So just pretty useful for doing that. Strip is basically required for 90% of stuff that deals with user input. 100% true. That is why strip is so useful. QCon, thanks for coming in, buddy. I appreciate it. Alexa, try myString : -1. I will. I'm not positive what this is going to do, but I will do it. It'll do something, for sure. Oh, yeah, it reverses it. You are 100% correct. I did actually know this, but it reverses the string. I tend to just type myString.reverse if I want to reverse a string, but you can 100% use. Is that not a thing? No, it's not a thing. Hold up. There is definitely a way to reverse. There's a way to reverse a string with a function. Maybe I'm losing my mind. Could have sworn I did that the other day, though. But yeah, I mean, that is a way to reverse a string. You're 100% correct, Hedgehog Grandpa. Thank you. That's a fun one. Reversed, is that it? Print myString.reversed. No, that still doesn't like it. There is some kind of something to do that. But : -1 is a lot shorter. You are correct. So those are some fun things to do with strings. We can also concatenate strings. So we can say if we have, let's just get rid of all of this now. So if we have buy my merch and then have string2 is equal to and throw bits at me, then we can say that my string plus string2, we can set that equal to new because it's a new string. When we print new, then we can... Oh, you used reversed. Yeah. Reverse is just a built-in function, and you would pass in the string. Okay, that makes it significantly more sense. That's what I was thinking of. But we can print our new string. This is just going to add these two together, and we will see that we now have buy my merch and throw bits. If we wanted to, we can also add in a space in there, and we can say, buy my merch and throw bits at me, because we now have the space. Looks a little bit nicer. We can concatenate strings like that. This is what we were doing earlier in our print statements. If you remember at the very, very beginning of the stream, I showed you the plus in here. Say we had a variable x that is equal to 10, and we wanted to add our 10 into here. This is going to crash. It's going to say that it cannot add because it cannot convert the int to a string. Hopdo, thank you for the bits. I'm just kidding, buddy. It's okay. It wants this x to be a string since it's adding it to a string. So that's when we can call the string function on it. And then it will successfully add our 10 to here. And just we'll add another, add a nice little plus space so that it looks nice. But now you have the buy my merch and throw bits at me 10. This is so useful. I just started with Python today. Well, welcome in, Marin B. I'm glad that this is helpful in every way. So that's just a little bit on strings. They're very useful. You're going to be handling strings a lot when you're coding. So get used to them. We'll be using them more when we do random examples as well. Let's look at lists because lists are a lot of fun. So what are lists? lists are your basic arrays in Python. If you're used to another language that uses arrays, some string times X, you can absolutely do that. That's a fun one for sure. So say we have a string hi, we can multiply that times a value, and it will print that 10 times. 100%. Hupto, you have a good time across country, buddy. Thanks for stopping in. Avoid ++ a string when you can. You can do a lot of unnecessary copies. Good advice from Userman as well. So that's a fun one. But let's talk about lists. They're basically arrays in Python. So lists use the kind of keyword of the brackets. And I know that we said that this was indexing. It's also how you create a list. So this is not creating an index. It's creating a list. But the nice thing about lists is we can store a bunch of different stuff in them. So we can actually define a list as, hello. We put a string in there. Let's also put an integer in there. Let's also put a Boolean in there. Let's also put a float in there. We can store all of these things inside of this list. And we can now index this list in the same way that we can index the string. So we can say list at 0, and we can print that bad boy out. And we will see that list at 0 is hello, because that's the first index of our list. We can also say list at 1, and this is going to print back our 1, list at 2, and so on and so forth is going to give us exactly what we want. Can you do multi-dimensional lists in Python? You absolutely can, and we're going to do something with that here shortly, because it is it's a fun example to do with the multi-dimensional lists. So we will show off that shortly. But just to clarify that what we have, Unstable, I know you're trying to cheer and put in some code in there. It does not like it. C++ is not better than Python. I disagree. You're trying so hard. I love it. But let's just clarify that what is inside of here is actually the different kinds of types that are in here. So we can say, there you go, Unstable with the 5 bits. Thank you so much, buddy. We can say type of list2. So this is going to pull, this is the 0 position, this is the 1 position, this is the 2 position. It's going to pull the type of list at 2, which this is a Boolean. And we will see that when we do that, it has class bool because it's a Boolean. Pretty exciting. Is this list stuff what people use in dialogue in games? Probably not. It's probably more strings when you're doing stuff like that. But I'm going to be honest, Papa. Most games are going to be working with objects, which we aren't covering today. We're not going to have time to. It's likely storing stuff inside of an object and then pulling that kind of data in. I can talk about it a little bit more on the Discord after this if you would like kind of some knowledge on how that exactly goes. But so we have different types being stored inside of our list, which is very cool. This allows us to store, if we're dealing with, say we have an Excel document that has a bunch of different kinds of stuff. So say it's, an order from Amazon. So it's orders in general. So we have the company name, then we have the date that it was ordered, then we have how many of it was ordered, how many, and then we have a description of what it is. And that's all stored in a file somewhere. We can read that in as a list, and we can say, okay, so the company is going to be a string. The date is going to be, either an integer or a date object, or a string also. How many? Guaranteed. That's going to be an integer. And then a description is also going to be a string. But we can store all of this in a list, and it allows us to know exactly where our data is and pull that data out so that we can use it, which is what is very, very useful about lists. And we can, as I said, index lists, which is very good. We can use a lot of the same commands with lists as well that we can use with strings. So we can say reverse, and then our list. I believe this works. It should. We can reverse the list, print that out, and you will see that we now... Okay, list reverse iterator. Okay, maybe we don't want to reverse our list, but we can do list dot reverse, list dot reverse. There you go. Not reverse the list. But if we reverse this list, you can now see we have none. Why are you none? This is why Python hates me. I try to do a basic example. Craps me on the bed. What if I just hit my mic? Did it mess up everything? I'm very sorry in advance. Don't try to reverse the list, kids. Userman, thank you for the follow. Much appreciated. Reverse do it in place. I don't know. That's one that I'm allowed to say. I don't know. I don't reverse lists a lot. So use the... Okay. So I suppose Hedgehog saying we could do this right here, and that's going to reverse our list as so. There you go. So that'll reverse our list for you. List.reverse mutates the object, so you need to call .reverse then print. Gotcha. Okay, that makes sense. That makes more sense. What other fun things can we do with lists? So we can append stuff to lists, so we can say list.append and then pass in something. So we can say this is appended. And then if we print out our list here, we can see that this is going to print our new list that has this is appended onto the back of it. Pretty useful. We can say, I just want to kind of run through some other list functions. We can say list.clear. That's going to clear out everything in the list. List.pop is going to pop off one of the things that we want to pass in. So we can say list.pop hello. And this is going to pop off. No, it's the index that we want to pop off. So if we pop off the 0th index, then this is going to pop off hello from our list. That can be useful as well. We can do dot remove. That's when we can actually remove a specific thing from it. So we can remove hello, remove that from our list. Pop passes in an index, remove passes in a an actual object in the list. So lists are pretty useful. And when we move into loops, which is kind of where I want to end the stream today, then we can see a lot of what is going on with appending stuff to lists in a loop and all kinds of stuff like that. So real quick, I want to cover conditionals before we do loops because I want to end with loops. So what are conditionals? Conditionals are, when you hear about programming logic, conditionals are the logical part of programming. It's using if statements to do some kind of logic and do a result based on that logic is kind of my best way of describing it. So let's declare a variable, x equals 10, because that's all we do nowadays. When are we going to dig into C Python code internals? Never, give or take. I would maybe do a GUI programming, but that's about as deep as I'm going to get with Python related stuff. So we can do a conditional that basically just says if x is equal to 10, then do something. Okay, and I'll just print do something. So what is the difference between a single equals and a doubles equals? Okay, so a single equals is used to assign a value to something. Okay, a double equals is used to compare a value to something. Think of a single equals as just saying equals. X equals 10. Think of a double equals as saying is equal to. So x is equal to 10 with a question mark at the end of it. Pretend there's a question mark at the end of it whenever you use a double equals sign. Okay? My throat's getting dry here. I've been talking nonstop. So we can actually, this is a Boolean statement right here. And I know we talked about Booleans earlier. We said, you know, that our bool is equal to true earlier or false. So this is actually a Boolean statement right here. X is equal to 10. So we can say, if we print x equals 10, this is going to return a Boolean because this is a Boolean statement. And we can print this, and we'll see that it's going to come back as true right here, because x is indeed equal to 10, and since this is a Boolean, it returns true. Does that make sense? So then we can use these Boolean statements in with our conditionals, with our if statements, to do stuff. So if x is equal to 10, then do something. And as you can see, our code did print do something because x is equal to 10. Now, what if x was equal to 11? Then it's going to say, if x is equal to 11, well, 11 is not equal to 10. So we probably are not going to print do something. And as you can see, it printed nothing because it didn't. All right, it was nice catching a stream for once, which is difficult because time zones, but I think I'll leave. You have a good one. Colonel Well, thank you for stopping in. It was nice seeing you, buddy. So then if we can do more stuff with this if statement. We can add in more statements. We can say elif, and this basically just stands for else if, for those that care. So we can say, well, elif x is equal to 12. If x is equal to 12, then let's do something else. Let's print do something else, you know? And then let's say, you know, if at the end, just an else. And this is going to be our catch-all. So we don't really put a condition for else. This is just going to say anything else, print, you know, we made it. Okay? Python does have the empty instruction pass if you want to do nothing. That is true. We talked about that earlier a little bit. So in this case, x is equal to 11. We're going to check. Isn't there like an or if? That's else if right here. Elif. Same as or if. So if x is equal to 10, do something. Well, x is equal to 11, so no. Elif x is equal to 12. Well, 11 is not equal to 12, so we're not going to do something else. Else, because it's our catch-all, it's going to do anything that isn't our first two conditions. Print, we made it. So then if we print this, we're going to see we did indeed make it. It says we made it. This was a successful conditional. Do we have that weird something, question mark, something operator? No, I believe, you might. You might. I'm going to be honest, I don't use it a lot. It's been a long time since I've had a class in Python. And I haven't really used, I use the question mark in C, but I don't know if I can do it in Python. No, like if x is equal to 10, or it, yeah, okay, yeah. We were going to get to that shortly, Cloud. More conditional statements, for sure. That's actually exactly where I'm going. You read my mind right here. So this is our basic conditional. Are there any questions on anything going on with this? I think it's pretty straightforward to understand this one, but if you've got questions, please feel free to ask. It's been a while since I've asked for questions, so I apologize. Is an or the pipes? No, it's not. Not in Python. We're going to see that shortly. Conditionals seem easy. Why not just type if twice? Okay, so that's a good point, Galahad. Okay, so let's say we had some conditionals here. Okay, if x is equal to 11, then print, here's the first thing we're doing. Okay, then if we have if x is equal to 11 or x is equal to 10, then print, you know, here's another thing we're doing. In this case, it's going to do both of these. Because first it's going to check, okay, if x is equal to 11, then print. Cool. Well, if x is equal to 11 or x is equal to 10, then print again. Okay, so when we run this, it's going to do both of them. Now, if we had this, it's not going to ever get to this. Because it's going to pass the first conditional, and it's going to do this, but then it's going to completely exit out of our conditional block. And it's not going to do this next one, even though this condition passes. Because x is equal to 11, so this condition passes. If we run this, it's only going to do the first one. So there are times where you want to have two if blocks if there's multiple things you want to do, but you also might not want to, you know? Okay, understood. That's good. That's good. So we kind of have a condition right here that we're working with this or. Can the if and elif both equal the same to print two different things, or would you rather use if twice? Can the if and elif both equal the same? I don't know if it'll let you. It very well might. We can test that. I can't really see a reason why you would ever want to do that, but elif x is equal to 11. That's 1. Then print, hey. We'll see what happens here. It might not like it because it's the same condition. No, it totally still works. It's just you'll never see this one if you want it to print that one, because it's going to pass on this condition, even if these conditions are the same. So there you go. But we can use some Boolean operators and or, which you can see bold up because they are keywords in Python. We can use these to do some more manipulation in our conditionals. And this is where logic really comes in. So let's say that x is equal to 11, y is equal to 10. Okay? So we can say that if x is equal to 11, or, oh, how about and? X is equal, and y is equal to 11. Double equals. Then print booyah. Okay? So what is going to happen here? So this is where you get into truth tables. And I really... Boolean logic is not where I want to bring this discussion today. But I will try to go over it very, very basically so people can somewhat understand it. So let's talk a little bit about a truth table. So here's what's going on. If we have a truth table for the function and, okay, this is an and truth table. We can say that there are two different things that x and y can be. They can be true and they can be false when we're talking about logic. So if x is true, well, let's go with the most basic condition. They're both not true, okay? So x is a 0 and y is a 0. Or if you want to think about this in terms of true and false, then they're both false if they're both 0, okay? So if false is anded with false, then that result is going to be false, okay? Pretty straightforward. Now let's say that x is false, but y is true. If we and those together, this is also going to be false because we need both of those to be good. Now let's go in the opposite way. If x is true and y is false, this is still going to be false because we need them both to be false. But if both of them are true, then this is going to be true. This is a truth table for and. Now on the flip side, and I'm just going to copy and paste this exact same thing in for an or truth table, this is going to be different. If they're both false, it's going to be false because this or this, if they're both false, they're going to be false. But if one of them is true, because we have an or, then that means that those are going to be true now. And this is where conditionals can get a little bit messy if we are using or and. You have to be a little bit careful. So I'm going to basically just enclose these in some comments so that we can still reference them, but it's not going to try and run this code and break into a million pieces. So if x is equal to 11 and y is equal to 11. Oh, you guys can't see these. Sorry. Let me attempt to bring that onto the screen. So there's our two truth tables there for and or, if you need to see those. Sorry about that. I forgot that I'd mess off a little bit of my my screen a little bit. Should be pretty straightforward to understand. They're basically just kind of the reverses of each other. So if we come back up to our function here, our conditional, is there XOR in Python? There is. XOR and not. I'm not going to get into all kinds of Boolean operators. Not we're going to cover, but I'm not going to get into other Boolean operators in this video. It's a little bit more complex, and I'm running out of time, and I still want to cover loops today. So if x is equal to 11 and y is equal to 11, so x is true because x is equal to 11, but y is false because y is equal to 10. Then we can come down here and we can say, okay, so and if the first one is true, the second one is false, then this is going to be false. So this conditional is not going to pass. And really, we can just, this is common sense a lot of the time, because you're looking at this, you're going, okay, yeah, if x is equal to 11 and y is equal to 11, y is not equal, so this isn't going to work. But this is what's going on behind the scenes. It's this kind of truth table here. So now we can say, okay, well, if x is equal to 11 or y is equal to 11, then print, hey, we made it. Read it. Okay. So Theodore Knights, thank you so much for the follow, buddy. So this is going to work now because we have an OR statement, and we can see, so if we head down to our OR, we had x is equal to 11, which is true. We had y is equal to 11, which is not true, but this is going to come back true because it's an OR. So this is going to print, hey, we made it to Reddit. And we can see this, hey, we made it to Reddit, successful, I love it, working fine. So we can use these and or operators in our conditionals here. Now we can do all kinds of whack stuff with conditionals. Let's make some kind of real disgusting diff. Welcome in, buddy. We can do all kinds of disgusting stuff here. So if x is equal to 11 and y is equal to 11, and we're going to put those into some parentheses, or x is equal to 11 or y is equal to 11, then print booyah. So this is disgusting in every way. Okay? Please don't create code like this unless you really need to. Let's dissect what's going on here. So x is equal to 11 and y is equal to 11. Okay? This is false. We know this is false. We just did this. So right now we can say that this is false. Okay? So false ORed with x is equal to 11 or y is equal to 11. Well, we know this is true. This was our other example. So now we have a false ORed with a true, which if we look at our table here, a false ORed with a true is going to be true. So this conditional is going to pass, and it should write booyah if I run it, which indeed it did. 100%. I've created the world's nastiest conditional that works out just fine. So cool. Also, real quick, I want to go back to an example with lists. I said that I was going to talk about a multi-dimensional list. Let's make a disgusting list. Okay, we're going to call our list L, and we're going to make our list a list inside of a list, inside of a list, inside of a list, inside of a list. Okay, and at the very end of that, we're going to say hello. Okay, so we have one list, two list, 3 list, 4 list, 5 lists. Okay? Let's index this list. Okay, so let's print L at 0, at 0, at 0, at 0, at 0. This is going to print hello because we have indexed the list at 0, so it's going to pull the first object in this list here, which is that list, and then it's going to pull the first object in that list, which is this list. Then it's going to pull the first object in that list, which is this list, and then it's going to pull the first object in this list, which is hello. So to the point of can you have multi-dimensional lists, there you go. There's your multi-dimensional list, which is disgusting in every way. Yeah, I should cover the len function as well. So len is pretty useful as well to get the length of a list or string. So if we have a string that is by my merch, as we had earlier, then we can print the length of that string with the len function. And we can print this, and we will see that the length of s is 12 because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters in our list. That's how you make 2D arrays. 100%. That is how you make 2D arrays. If I had an example ready, I could do a fun thing with tic-tac-toe. I'll set it up for next time, since I think we're probably going to do another one of these because you guys really enjoyed it. So that's cool. Now we can do we can print the length of our list here. And this you're actually going to find to be an interesting answer. So if we print the length of our list is 1. Did anybody expect that? Because it's a little bit weird. There really is only one object in this list, and it's this list right here, enclosed by, you know, this bracket and this bracket. It's just the fact that we have lists inside of here that's making it look a little bit funkier. But as a whole, there's only one object inside of this initial list, so the length of that list is 1. I'm going to stop for questions before we do loops very, very quickly. And loops are fun, so I want to make sure I cover them because you guys are going to be able to do a lot with lists now that or do a lot with loops once you learn them. And then you can send me cool looking turtle stuff in Discord, and I'm quite excited for it. So any questions? So you're going in an order with what you teach. I mean, I don't teach, but I am going in basically order of how you should learn Python, Jay. And since you just came in, all these videos will be on YouTube if you want to see them later. What about tuple sets and dictionaries? I'm not going to cover tuple sets or dictionaries in this video. That's a lot of that's a lot to start getting into. Control A to select all tests and backspace. I'm aware of Control A. Thank you. Yeah, we will we'll talk about tuples, sets, dictionaries. I don't use sets a lot, but I will talk about tuples and dictionaries in a future stream. Not today though. Loops. Let's do loops. Okay, there's 2 types of loops. We got while loops and we got for loops. Okay, these are the 2 main ones I'm going to talk about. You can have like different variations of these, but for the sake of beginner Python, which is what this stream is all about, we're just going to talk about while and for. I'm going to start with while, and in a lot of ways, while is a little bit more complicated than a for. So if you understand while loops, you're going to be all set to understand for loops. So let's do our basic x is equal to 10. Very straightforward. And then let's create a loop. And this is going to basically, you're going to start with the word while, which is just our keyword for starting a loop. And then we're going to put in a Boolean condition. So we're going to say while x is not equal to 0. And this introduces the not operator. When Vijay, welcome in, buddy. I am happy you're here. The exclamation point represents not. And we can actually, let's do a couple examples with this operator that I did not cover earlier. So we can say print, let's say we have a variable x equals 1. Let's print x is not equal to 2. This is a Boolean statement. If we print this, since x is not equal to 2, it's equal to 1, this prints true because that is correct. Sounds good? Sounds good. Very basic. Exclamation point just means not. So x is not equal to 0. So while x is not equal to 0, I want you to subtract 1 from x and then just print out that x value. Okay? So what is this code going to do right here? X is equal to 10. And then while x is not equal to 0. So right now x is not equal to 0. It's equal to 10. So we're going to jump into the loop. And the loop, as always, separated by white space. Very important in Python. We're going to subtract 1 from x. So we're going to get down to 9. And then we're going to print 9. Well, then it's going to jump back up to the top because we're looping. And it's going to check again. Well, is x not equal to 0? Well, it's 9. 9 is not equal to 0. So yeah, we're good. We're going to hop back into our loop. It's going to say is x, we're going to do x minus equals 1. It's going to become 8. We're going to print 8. And then it's going to loop. And it's going to check, okay, well, is 8 not equal to 0? 8 is not equal to 0, so it goes in again. And this is going to go all the way down to 0, as we can see right here. And it has printed out 9 through 0, as we would expect it to. And life is good. You don't need an end in while loops. You do not. This is the basic syntax for a while loop. There are different variations of it that you can kind of mess with in Python. But for a basic while loop, this is all I'm really going to cover right now. So what we can do is we can introduce a break statement in here if that's something that you really want. So say we only wanted, we're starting at 10, but we want to stop at 5. You know, I don't really want to go all the way down to 0. I want to stop at 5. So we could just say if x is not equal to 5. Sure, we can do that. But I don't really want to. I want to keep that at 0. I want to introduce a statement in here that says if x is equal to 5, then break. And the break keyword is used to break out of a loop. You know, if we meet this condition, we're going to break out of a loop. So if we run this, we're going to see we only go to 5 now, 98765, because we're breaking out once x is equal to 5. We can also, we don't need a condition to do this. We can just say print x and break. Okay, so this is going to print 9, and this is going to break. And it's going to get the hell out of there because it does not want to. It does not want to be in there. Unstable Python is best used for scripting, backend for websites. Yep, as well. Machine learning, scripting. It's basically the #1 tool for security at this point because of how well it is as a scripting language, but. Very useful. Have a good one, Unstable. So if you put a loop in a function and break it, will the value of x still be 10 when the function is finished? I don't know if you're memeing or not. Because we can set up this example. I'd be happy to. But I don't know. I don't know if you're memeing. Because I'm not. Okay, let's set up this example. I'm ready for this. So let's define a function. Add 1, and in that function, we're going to pass in a variable x. We're going to have our loop inside of our function, and we're going to have x equals 10 outside of here, and then we're going to call add 1 on x. We're going to set a new value of x equal to add 1x, and we're going to print x. Is this essentially exactly what you're asking? Because if this is what you're asking, then I'll walk through this. If not, then please correct me with how you would like it to be set up. Hedgehog knows exactly what is going on here. Okay, cool. So let's talk about this. As we talked about earlier, if we want to get a variable back from a function, then we need to return it. Breaking here, so we're going to enter into our loop, and it's going to do this, but then it's going to break our loop, and this is going to get to this line right here. And it's going to go, I don't know what to do, so it's just going to go back. And it's going to come back to here, and it's going to say, okay, well, x is equal to, dude, I don't freaking know, because we didn't return anything from this. So this is actually going to turn x into the variable none. Okay, and we can see this right here. When we print x down here, it's none. So what is this magical keyword of none? So none is essentially is nothing. It's just, it doesn't exist. It's this placeholder variable that is none. It's nothing. And this happens more often than you would think. There are a lot of times where you want to check if something is none, and we can do if statements that are like, well, if x is none. Because is, so what's the difference between equals and is? Is checks types, okay? So is, we can say up here, if x is int, that might work, actually. I'm not positive. Then print x. Tell me that works. No, absolutely does not work. Oh, no, it absolutely maybe does. Hold up. Do you like that? Yeah, it does work. Okay, cool. So if x is int, then print x. So it's checking if x's type is an integer here. Maybe. Maybe that's not doing anything. No, that's not doing anything because it's not printing that. Just ignore me. I'm randomly BSing my way through random Python syntax. I'm not here to talk about is. Is not that important for what we're doing. Is instance. Yeah, that's what I want. Is if X is instance of if it yeah, there you go. That's what you want. Thank you, user man. That's what you would want to check if X is an int. But you can use is to check if something is none, which is pretty useful. But anyway, if we wanted to, we can do this then. And this is going to return X as 9 now. Because we set it equal. Correct? Are we all on the same page? Brontalo, welcome in, buddy. It's awesome to see you. It's always awesome to see you. Alternatively, if X is not none, it absolutely works as well. The not keyword is also one that you can use in conditionals. So does that make sense, Galahad? Hopefully that makes sense. Let's talk about for loops to end off the stream here. Gweemkaz, thank you for the prime sub, buddy. Everybody spam your Alexa loves who have them. For Gweem here. Welcome to the family, buddy. So let's talk about for loops. For loops have different syntax. We create a new variable in our for loops. And it's similar to our functions. It's a variable that we use inside of our loop, but then we don't necessarily have outside of the loop. You know, it's contained inside of our loop. So we can say for X in range 0 to 10. Okay? So for X in range 0 to 10, let's print X. Okay? So what is this going to do? It's going to say, okay, so in the range 0 to 10, we already know, we talked about this earlier, it's going to be inclusive here, it's going to be exclusive here. So it's going to start at 0, it's going to go to 9. It's going to print out those values. It's pulling this X value is what this is doing. Okay, it's going to loop through these values and print them. And we can see this right here. It prints out starting at 0, going up to 9. Makes sense. We can also turn this around and do that. And that's going to possibly explode. But yeah, okay, it definitely exploded because going in a weird direction. Don't do that. X in range 10. Yes, you can also do that. X in range 10. And it will go 0 to 10 there as well. But I tend to consider it a good coding practice to clarify where your starting position is going to be, even if you're starting from 0. Just because in most cases, you're going to be starting somewhere else in here. So, but just my own personal coding practice to do that. That's a basic for loop. The nice thing about for loops is we can actually use them with everything. So, try explaining this in Human Resource Machine. Human Resource Machine is a different kind of coding language. That's assembly, and I hate assembly, which is why I don't care for Human Resource Machine. But we can do, okay, so say we have a string here, string 1, and we're going, I'm just going to make it S for the sake of, for those, I can't see my keyboard a lot of the time, and my keys are all messed up. So S is equal to, buy my merch, as this is my normal string now. We can loop within this string. So for each character in S, then print character. So what is this going to do? This is going to take each character from S. And for the record, I don't have to say character. I can say X. I can say Tyler sucks. You know? Your variable name does not matter in here. It's just usually a good coding practice to do this. You know, make your variables make sense in your code. But you can say, so for Tyler sucks in S, print Tyler sucks. And this is going to take each character of our string here, which is pretty cool. And we can print this, and you will see buy my merch is going down because we're printing each, and it adds a new line at the end of each one. If we wanted to, we could do end equals this, and this is going to not put a new line at the end of it. And we can now see buy my merch just like that. But pretty cool. We can also then, you know, say we have a list You know, we have a list in here that has hello, 1 or 2, 4, 5. That's our list. We can say, so for Tyler sucks in our list, let's print out the stuff in our list. And we can print this, and it's going to print out the stuff that's in our list as well, which is pretty cool. Does that make sense? Do we have any questions on that? Because that's basically where I'm going to end off the stream today. It's good practice to put Tyler sucks in your code as much as possible. Very true. Are there any questions for loops or any questions about anything that we've covered today? Including stuff we didn't cover that I can try my best to give a quick answer to. I had to leave for 5 minutes. Did I miss a lot? I think you missed pretty much all of loops, but I can cover them in the Discord again if you need some help. For loops entirely, I can help you in the Discord after. Any other questions? Every function / variable should be named Tyler sucks _number. What's the meaning of life? It is sex, drugs, and rock and roll. Didn't cover when is Magica coming. Oh, Brontalo. I'm sorry. No questions. Just want to thank you for an amazing stream. Thank you guys so much for coming out here. What about pictures? What do you mean pictures? That's a great question. What about pictures? There's a lot you can still do in Python. Keep in mind that this is the beginner. You know, you can eventually use Python to manipulate files. You know, we'd cover file IO in the next one if I do another one. But you can manipulate files on your computer. You can just open files on your computer. You can shut down your computer. You can, like, there's a lot of powerful stuff that you can do in Python. It's a very versatile language. Modules just add even more to it. I've been messing a lot with, there's a module called, and I don't have it installed on my computer. I was messing with it at work. It's called OpenPixel. And OpenPixel allows you to, I don't know if I can find it and download it here. No module named OpenPixel. Yeah, okay. Well, there's a module named OpenPixel. It allows you to essentially read and open Excel documents. And you can mess with Excel documents and do formatting in Excel and all kinds of stuff. Crazy useful module to do stuff. But you can execute system commands. You can everything. Hedgehog, you're 100% correct. Thank you for the follow as well. You could do a lot in Python. I heard create viruses. You can create viruses in Python. I'm not going to lie. But don't do that. How often this kind of live stream are going to happen? I love it. I don't know how often I'll do these, but I do want to get back to creating coding videos on the channel. So maybe we'll see more on the channel. If some of you are here from Twitch and not from YouTube, then I highly recommend you go check out my YouTube. I usually do gaming stuff, but I want to get back to doing more coding tutorials on there. I already have some on there, a little bit more in-depth recursion. I did a cool little encryption example and some other fun stuff, so you guys can check out those there. But I do want to do more programming on Twitch. I think it'd be fun. You know, some kind of big project at some point, make some kind of game or something. You know, Minesweeper could be a fun time. But that's going to do it for today. As long as there's no more questions, I'm going to take off. Thank you, everybody, so much. I had a lot of fun doing this. Hopefully you learned a thing or two in this stream. If you have any questions, just go into the Discord. Ask to be a coder in either FAQ or suggestions. 2 of the chats in there. I will make you a coder. You'll then have access to the coding chat, and you can ask questions or show off stuff that you're coding in those chats. But it was a lot of fun. Thank you guys so much. I'm going to put on some music to end the stream. I'll still be in chat if you want to talk a little bit, but that's going to do it. Thank you guys so much. I gotta get the wait a minute, and transition. Thank you for watching. I'll see you next time. Bye bye.